Let us start topic Markov source, right? So what are the things required to solve this problem, right? So here we required entropy of each state, right? The first point is entropy of each state. Entropy of each state. So entropy of each state. In order to calculate entropy of each state, we have a formula like hi equal to summation j equal to 1 to n pij log 1 divided by pij, right? And also we required entropy of source. Entropy of source. So to find entropy of source, h equal to summation j equal to 1 to n pi hi. As we know that pi is called it as probability and hi is called it as entropy of each state. Entropy of each state. Entropy of each state, right? Okay, let us start with problem, right? Problem number P12. Yes. All of you note it down. For the Markov source shown in figure, for the Markov source shown in figure, find the entropy of each state, find the entropy of each state and the entropy of the source, and the entropy of the source. And third point, G1, G2, G3. So we will see later, right? First we will practice more problems on this entropy of each state and entropy of the source. So after that it will be very easy to understand G1, G2, G3 how it has to be solved, right? So first we will only see the entropy of each state and entropy of the source, right? So we will practice more problems on entropy of each state and entropy of the source. And it is extended a version of finding the entropy, right? So let us take state diagram. Here we have total 3 states, state 1, state 2 and state 3, and 1 to 2 going with the probability of 1 by 4 and 2 to 1 with the probability of 1 by 4. Similarly, and 1 to 1 which remains in the same state with the probability of 1 by 2, and 1 to 3 with the probability of 1 by 4 again, 3 to 1 with the probability 1 by 4, and similarly remains in the same state with the probability of 1 by 2, and 2 to 3 and 3 to 2. 2 to 3 with the probability of 1 by 4, 3 to 2 with the probability of 1 by 4, and 2 to 2 in a same state 1 by 2. This is the state diagram of given problem. This is the state diagram of given problem, right? So here they are going to give the state diagram also, right? Here what we need to find? Here we need to find the entropy of each states as well as entropy of the source. Entropy of each state and entropy of the source. Now how to find entropy of each state, right? Now we'll see that. As we know that what is the formula to find entropy of each state? That is, call it as HI equal to summation j equal to 1 to n Pij log 1 divided by Pij. This is the formula to find entropy of each state, right? So what? Entropy of each state means here total we have three states. State 1, state 2 and state 3. So we need to find the values for state 1, state 2 and state 3. So first I will be going with state 1. State 1, right? That is H1, right? I equal to 1 here, H1, right? Then how it has to be? Now here I will be expanding this summation by putting the value. Now the state 1 which is related to, like, state 1 will be remains in a same state, like with the probability of 1 by 2. So P11, P11 indicates that which remains in a same state from 1 to 1. From 1 to 1, P11 log 1 divided by P11 plus total we have three states. Now is there any connection between 1 to 2? We should check that also. From state 1 to state 2, is there any connection? Yes, of course. It is moving from state 1 to state 2 with the probability of 1 by 4. So that is why we need to take P12 also. P12 log 1 divided by P12. Similarly, is there any connection between 1 to 3? Yes. So P13 log 1 divided by P13. In this way, we need to expand the summation, right? If we have a connection, then we should check what is the probability. If there is no connection, then it has to be assumed it as 0. It has to be assumed it as 0. Now I will be substituting the value of P11, P12, P13. So right, what do you mean by P11? It is probability of 1 to 1. P12 is called it as probability of 1 to 2, means state 1 to state 2. And P13 is probability of state 1 to state 3. Probability of state 1 to state 3. Now let us see that. Now 1 to 1 is nothing but remains in the same state. What is the probability to remains in the same state? This 1 by 2 is the value, right? 1 by 2 is the value, right? 1 by 2 is the value of P11. So I will be substituting that value here. 1 by 2 log 1 divided by 1 by 2, as it is required in terms of bits, divided by log 2 must be done. Plus 1, 2. We should check, right? As I said that 1 to 2 is nothing but connection between from state 1 to state 2. So connection between state 1 to state 2, right? Here it is. State 1 to state 2 with the probability of 1 by 4. So I'll take 1 to P12 is 1 by 4 log 1 divided by 1 by 4 divided by log 2 plus 1, 2, 3. Again there is a connection here, right? 1, 2, 3 with the probability of 1 by 4 again, with the probability of 1 by 4. So 1 by 4 log 1 divided by 1 by 4 log 2. Now calculate what is the entropy of state 1. Calculate and get the value. What is the entropy of state 1? Yes, very good. 1.5 bits per symbol. Very good. 1.5 bits per symbol. Good. 1.5 bits per symbol, right? Understood now? Yes. Now we will see that state 2. State 2, right? State 2, right? Now, what is the formula to find a state 2? So first it should be P21 because from state 2 to 1, P21 log 1 divided by P21 plus again from same state P22 expanding the summation P22 log 1 divided by P22 plus from 2 to 3 P23 log 1 divided by P2 P23. Now what is the value of P21? As I said that there should be a connection between from state to state 1 with what probability? Let us see that, right? So what is a P21, right? This is second state from 2 to 1 with the value of 1 by 4, this one. Connected 2 to 1 means from 2 to 1 it is going here with the probability of 1 by 4 and 2 to which remains in a same state with the value of 1 by 2, this one, and 2 to 3 1 by 4, 2 to 3 1 by 4. Now we'll see. Yes, again H2 1, okay, 1.5 bits per second, very good. Yes, so 1 by P21 is 1 by 4 log 1 divided by 1 by 4 divided by log 2 plus 1 by 2 log 1 divided by 1 by 2 divided by log 2 plus 1 by 4 log 1 divided by 1 by 4 divided by log 2. So H2 equal to 1.5 bits per symbol, right? Similarly now state 3. Again expand the summation. First I'll take 3 to 1 log 1 divided by P31, 3 to 2, very good. 3 to 2 log 1 divided by P3 to 2 plus P3 to 3 log 1 divided by P3 to 3. Now again you should find what is the probability of P31. So from 3 to 1, again it is going with the probability of 1 by 4. Again it is going with the probability of 1 by 4. So that 1 by 4 log 1 divided by 1 by 4. Again divided by log 2 because I want to convert this value in terms of bits. Again 3 to 2 with the probability of 1 by 4. 1 by 4 log 1 divided by 1 by 4 divided by log 2. As I said that why we are going to do with log 2, because that value should be converted into bits. And 3 3 which remains in the same state with the probability of 1 by 2 log 1 divided by 1 by 2 divided by log 2. Again it is same, right? 1.5 bits per second. Very good. H3 is also 1.5 bits per second. Same, yes, good. 1.5 bits per second. So we found that what are the entropy of each states, right? What are the entropy of each state? Now we should find the entropy of source. We should find the entropy of source now. Entropy of source is denoted as capital H summation I equal to or j equal to 1 to n or I, right? I equal to 1 to n pi hi. This is the formula to find the entropy of source. Entropy of source. Now H equal to P, like we have total 3 states, J equal to 1, oh sorry, I equal to 1, 2, 3, Pi, Hi. So P1 H1 plus P2 H2 plus P3 H3. So I forgot to dictate what is the value of P1, P2, P3, right? Has been already given those probabilities in your problem, right? P1, P of 1 equal to P of 2 equal to P of 3 equal to 1 by 3 has been already mentioned in the problem, right? P of 1 plus P of 2, sorry, P of 1 equal to P of 2 equal to, yes, all are 1 by 3. P of 3 is equal to 1 by 3. It is given data. It is given data, right? Given data. Now you know that what is P of P1, P2, P3. Even you have found already what is H1, H2, H3. Substitute and get the value. I'll mute tagdiದ್ರು. Right? Substitute and get the data. Therefore, H equal to 1.5. Yes, 1.5 bits per symbol. 1.5 bits per symbol because 1 by 3 into 1.5. Yes, bits per symbol, right? Plus 1 by 3 into 1.5 plus 1 by 3 into 1.5. Again, it is 1.5 bits per symbol. Yes. So that G1, G2, G3, we will see it later. After practicing more problems, we will go with G1, G2, G3, right? Is that clear? Yes. Okay. Any doubts? Yes. Okay. Understood, sir. Okay. So we will take, okay, next problem, P13. Understood. Good. P13, right? P13. You see this. For the first order Markov source with the source alphabet A, B, C shown in figure, calculate the probabilities of states. Calculate the probabilities of state. It means that entropy of each states. Right? Find H of S and H of S square. H of S is nothing but entropy of source. H of S square is entropy of source, second extension, right? So he has been given state diagram. Okay. So see problem number P13 for the first order Markov source shown in figure, right? A, B, and C. These are the states. What is the probability? P here, and A to B, and A to B with the probability P. Again B to B with the probability P. C to A with probability P, and B to C with probability P. This has been given. Now you need to find the entropy of each state. right? Find the probability of states also, because in previous problem he has been mentioned what are the probabilities. It means P1, P2, P3 already has been given 1 by 3, 1 by 3, 1 by 3. But here he has not given what is P of A, P of B and P of C. First you need to find probabilities of all the states, and later you should go with probabilities of each state, that is entropy of each state, and finally source of entropy, right? Now we'll see how to find the probability of each state when he has been not given. The probability of each state is called it as P of A. I don't know what is P of A. I don't know what is P of B because he has been not mentioned in your problem. First we need to find this P of A, P of B and P of C. How it has to be found, because in previous problem here he has been mentioned what is the probability, like 1 by 2, 1 by 3, 1 by 4 he has been given it, but here there is no any value. So we need to find what is P of A, what is P of B and what is P of C. Then how it has to be found, right? So here to find that probabilities, to find probabilities, there will be a procedure like which entering into the state should be considered, which entering into the state should be considered. Entering symbols are going to consider to find the probability of each state, right? Now I will be going to write the equation for state A. Now see, the first with the probability of P which is entering into the same state. See this symbol, entering into the same state, right? Entering state. What is the probability? Entering into the state with the probability of P, with the probability of P. So I will be writing P of A equation, entering with the same state with probability of P into P of A, plus from A to B it is not entering, A to B it is leaving, A to B it is leaving. But I want only entering states. I want only entering states, so that C is entering into A with probability, C is entering into A with probability of P. So I will be considering with probability which state is entering. P plus P into P of C, equation number 1. Similarly, try to write for all the states, P of B and P of C. Now see, P of B. P of B should remains in a same state with probability of P. Yes, because it is entering again. So P into P of B, and again which state is entering, either A or B. A is entering but B is leaving, right? A is entering, A is entering into B but C is leaving. So P into P of A, equation number 2. And equation 3, I should draw here one more state, right? With probability, C remains in same state with the probability of P into P of C, plus again which state is entering into C, B is entering, P into P of B. So this equation should be written based on entering, based on entering states, based on entering states. These equations are written based on entering states, right? Is that clear? Okay. Now, next, what I am going to do? We know that sum of all the probabilities are always equal to 1. We know that sum of all the probabilities are always equal to 1. So I'll take that condition to find, I'll take that condition to find P of A, P of B, P of C. So P of A, sum of all the probabilities, P of A, P of B plus P of C is equal to 1, right? P of A plus P of B plus P of C is equal to 1. Why I have written it in this way? Because sum of all the probabilities are equal to 1. We know that, right? We know that sum of all the probabilities are equal to 1. Now I wanted to find P of A, P of B, P of C. How it has to be found? By solving simultaneous equation. By solving simultaneous equation. Now we know the three equations, P of A, P of B, P of C. Now what I'll do? I'll convert the equation in such a way that which will be very much equal to others, right? Right? Now what I'm going to do? Now let us see what I'm going to do it now. Now this equation must be converted into, like, first I'll take equation number 1. I'll take equation number 1, so that equation 1 can be written it as, equation 1 can be written it as P of A minus P into P of A equal to P into P of C, right? So convert all P of C or P of B should be in one form, right? Even we can solve like whatever. If you have, like, you can use it by substituting method also, whichever you feel easy, right? P of A is equal to 1 minus P into P of C. Yes. So here I'll go with this. P of A can be converted. Now P of P can be converted into P of A. Yes, of course, it has to be converted with the help of this equation, right? Now P of A has been converted into P of C, or P of C is converted into P of A. Again, P of B is also converted into P of, right? Now I'll take one more equation, P of A, second equation. Second equation can be written it as, how it has to be written? Second equation should be converted into A again. P of B equal to 1 minus P equal to P into P into P of A. So P of B is also equal to P divided by 1 minus P into P of A can be taken. Here also it has to be taken it in that way. Here P of C is equal to 1 minus P into P divided by P of A. Now substitute these two in this equation to get one value. Substitute these two in this equation to get the value. Now P of A should be substituted as P of A only. P of A plus P of B is substituted as P into 1 minus P of A. Alright, plus P of C 1 minus P divided by P into P of A is equal to 1. Now try to solve this, right? Try to solve this. We will get the value of P here. I'll take P of A common. 1 plus P into 1 minus P plus P equal to 1. Now solve this equation to get the value of P of A. No, 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 no. No, no, it is very sorry. I should find the value of P, not P of A, right? I should find the, right? So let us take this. Now what I am going to do, sorry. So what I have done, we know that I want to have the value of P, right? P of A plus P of B plus P of C is equal to 1. We know that what is P of A? P into, from equation 1, P into P of A plus P into P of C. What is P of B? P into P of A plus P into P of B. What is P of C? P into P of B plus P into P of C is equal to 1. Right? Now P into P of A, P into P of A. 2P into P of A plus P into P of C, P into P of C, P into P of B, P into P of B. So 2P P of B plus 2P P of C is equal to 1. Is equal to 1. Now I'll take 2P common. P of A plus P of B plus P of C is equal to 1. As I know that P of A